good afternoon. So today we're going to discuss about the another one qualitative analysis part. Last day we have performed the same type of experiment, that was oxalic acid versus sodium hydroxide. Now today it is the next one, that is we have to find out the strength of HCl solution by using a standard sodium carbonate solution. So we have to find out the strength of HCl solution by titrating it against a standard solution of sodium carbonate. Okay, so last day, if we compare with the last day, the experiment we have performed on the last day, that was oxalic acid versus NaOH. The strength of NaOH was not known to us, but the strength of oxalic acid was known. But now today, the strength of that base, that sodium carbonate, is known to us, but the strength of acid is not known. Okay, so today's aim of this practical is determine the molarity and strength of given HCl solution by titrating it against a standard solution of sodium carbonate. Okay, so just I am writing down the aim. Determine the strength and molarity of given HCl solution determine the strength and molarity of given HCl solution by standard sodium carbonate solution. By standard sodium carbonate solution. This is the aim of this today's practical. Okay. After the aim, we have to go with the theory. So theory part, it must contain, in theory part, it must contain the equation involved. So the equation here, that is the reaction between just an acid-base reaction. So sodium carbonate plus HCl. What is the product? That sodium chloride plus CO2 plus H2O. So this is the balanced chemical equation. 1 mole of sodium carbonate consuming 2 moles of HCl. This numerical proportion is required when we will calculate calculation portion. Just remember it. 1 mole is the numeric stoichiometry of Na2CO3 and 2 is the HCl. And what is the indicator here? So as the endpoint belongs to that acidic region, because this I am discussing about from practical, this is not of project. So this time indicator, this time as the endpoint belongs to acidic range, so this will be the methyl orange we will use. Methyl orange. And what is the change in color? So we are adding methyl orange on basic solution. So the color of methyl orange in basic solution is yellow, and at the end point when it turns to acidic, it will be pink. So it is conversion of yellow color when you will add to pink color at the end point of that titration. So this is the equation involved. This is the indicator required. This is the color change. This is come from the theoretical portion, theory part. After that is that materials required. Materials, the laboratory instruments, pipette, burette, etc. obviously will require. With that, what are the solution you will require? That prepare 250 ml M by 20 sodium carbonate. Prepare 250 ml M by 20 sodium carbonate solution. Okay, and with that we will use that indicator, that is methyl orange. Now our next work to do that part, that preparation of 250 ml M by 20 sodium carbonate. Okay, so how to do it? So we know that as we have prepared it in molarity, capital M means molarity. This is the strength of the solute in a 1 liter of the solution. When 1 mole is dissolved in 1 liter of the solution, then it is called as 1 molar. Okay, so here we are preparing M by 20, just 250 ml. So for this, to prepare 250 ml M by 20 sodium carbonate, we should wait. This is equal to the molar mass of Na2CO3 into 250 divided by 1000 into 20 gram of Na2CO3. This is equal to molar mass of Na2CO3 is 106, 250,000 into 20. This is equal to 1.325 gram. So now is the work start. Yes, this is the next practical. This is experiment number 2. When it will be a new title, it will be a new practical. So it is 1.325 gram. You have to weight from weighing machine. That is sodium carbonate. Solid sodium carbonate, you have to weight 1.325 gram. Okay, next part is the preparation it with water, the distilled water. Okay, next is that HCl will be supplied and indicator will be supplied. No other reagents is required. So after preparing the solution in the volumetric class, just transfer it into the beaker so that it becomes easier to keep it out. Okay, and adjustment of the fingers is very important in the pipette because you have to take a specific amount. So for this you have to be, it is called as the settlement. Okay, that the fingers will settle at the mouth of that pipette, and how you can manipulate it, it depends on you. Basically it depends on practice. How you will practice, it will be easier to you. Okay, now you can see the lower half also. So this is the materials required and this is the mass you have to take. Now I will go for that. For the calculation, for the observation of the data, that we have to do the experiment number 1 is determine the strength and molarity of given NaOH solution by standard oxalic acid solution. Now I am going to the next slide. Auditro, you are first time attending the class? Now the right side is clear. In the bottom I have written weight equal to molar mass of sodium carbonate. This is molar mass of sodium carbonate into 250 divided by 1000 into 20 gram of sodium carbonate. Now the molar mass is 106 gram. 250,000 into 20, that will be equal to 1.325. For which practical you are saying about that, the last part we have to write from internet. That experiment I will show you like the previous day. No, this is not the part of experiment number 1. It is not the part of experiment number 1. It is the preparation of sodium carbonate. That time it was oxalic acid. Oxalic acid versus NaOH. This is Na2CO3 versus HCl. It is just the same type, but the weight is different. Norin is saying rest takes part. Rest takes part, that means from materials. From materials. No, you have to add some points extra. That is, I have just mentioned only 2 materials. You have to add here the pipette, burette, etc. All are these. And then the procedure will come. In procedure section, you will write the preparation. Prepare the 250 ml m by 20 oxalic. Okay, taking it 25 ml in a conical flask. Add just 2 or 3 drops of methyl orange indicator. Then titrate it with HCl solution. Now I am going to the part that is the next part. Second part. There, that is the calculation part. Okay, so just observe it. This is the wing bottle and I have weighted 1.325 gram previously. Now you can hear properly. Now you can hear properly. Okay. Okay, so this is 1.325 gram as we have calculated. So this is already weight taken. Okay. This is the 250 ml volumetric flask. And listen one thing, that apron in the lab is very essential. Without that, you cannot enter to that laboratory. So everyone have to collect the apron. This is a part of laboratory. Okay. So for this, everyone be careful regarding to that. Now, how to prepare the solution? So this is 250 ml of the volumetric flask, and when you will prepare a solution, just take the distilled water from the bottle. This is the transference of the sample. Now add distilled water. Okay. Shake it well so that it is totally dissolved. You have to titrate it thrice. That is, you have to take 3 concordant razors. For this, you may have to titrate more than 3 times. Okay, now you have to add water to it. But when you will prepare the solution, you will use the distilled water, not the tap water, because it will may turbid the medium. Okay. Now carefully you have to observe the line present here. Here is that line. I have prepared that solution. Okay. Now keep it reserved. This is the HCl. It will be supplied to you. The burette should be filled with that HCl. So when you will transfer the HCl, just there will be the beaker will be given there. Just observe that how this is done. Beaker will be given there. Just transfer it in that way. And every time when you will do that, just make sure that the mark is on 0. Okay, observe it. This is the mark of 0. Mark of 0. Okay. This is the burette. This is the burette. And here is that knob. If you make a parallel to it, then from this the solution will come. This is the locking position, and this is when it will be parallel, it is the unlocking. And controlling this knob, you can adjust the speed of that liquid. Okay, so now I will hang it on the stand. Next step is that pipette out 25 ml from that, from the stock solution we have prepared. Pipette 25 ml. So this is the solution prepared. That is, I am telling about the adjustment of finger. Transferring it to the conical. Transfer completely. Now add indicator. This is methyl orange indicator. Change the, observe the color changes. 1 drop, 2 drop. Just it becomes yellow. You can see the color is yellow. Now the end point will be pink. Okay. Now we can go for the titration. observe the color. Everyone can see the color. This is the pink, but it seems to be red. This is the end point. Now we have to take the reading. So this is 24.8. First reading is 24.8. That how to take the reading? There is a mark in the wall. There is the mark, and you have to make parallel to your eyes that reading and take this mark. This is 24.8. Okay, so this is the first reading. Next is that again fill up the burette with HCl, because we have to make another one titration. You have to do it thrice. So 3 times you have to fulfill the volume of that burette. So what was the first reading? 24.9. Okay. Next is that again we have to pipette out, reject the previous solution. Reject the previous solution. Pipette out 25 ml again. Add it in the conical flask. Transfer completely. Now add 2 drops of indicator. It becomes yellow. Now titrate it with HCl. The end point will be pink, just like the previous. Don't run the solution from burette continuously. Just add drop wise so that you can find out the end point easily. Okay, again it is just the same color, pink color. Okay, so this is reading. Now time to take the reading. It is 25. It is 25. Okay, and when you will write it in your lab manual and also during the exam, it will be near to 25. That is, it may vary within the range of 24.7 to 25.2. Okay, this you will remember that you must not overcome that range. If you want to write 24.7, then your 3 reading will be 24.7, 24.8, 24.7. Take 25 ml, then if it will be 25.1, then 25, again 25.1. Okay, so in that way we can complete that observation part. Now I will show you that observation and calculation part, that is the third part of that practical in the board. So keep watching on this section, that observation and Now the observation should be in the tabular form. Now I am rubbing this part. Quickly you will write that record. Observation. Okay. So observation number, volume of sodium carbonate taken in milliliter ml. From where we will got that ml mark, that the burette is of 50 ml. So from where it is 25 ml. Concordant result, concordant value of HCl in ml, average value of HCl consumed, average value of HCl consumed. Okay, so you have to write this in this tabular format. Observation number 1, 2 and 3, 25 ml each time. Volume of HCl, this is 24.9, next 25.0, and 24.9. Okay, average value, that is 25.06, 24.25. This will be just about 24.89, 24.89 ml. Okay, this part is completed. This is the part of concordant. Now look at this result very carefully. Just a difference by 0.1. Just a difference by 0.1. This is very important. Third block, concordant result. Concordant value of HCl consumed. Concordant value of HCl in milliliter ml. And last column is about average volume of HCl consumed. If you have completed this part, then tell me that we can proceed to the calculation. First column, observation number, next volume of sodium carbonate taken. I think now you can see. Okay, so write down very quickly. Observation number, volume of sodium carbonate taken, concordant value of HCl in milliliter, average volume of HCl consumed. Okay. Now I am moving to the calculation. Hope everyone have written it. Okay. Now the calculation part. calculation. So in the same manner we can do that. M of HCl, molarity of HCl into volume of HCl consumed by M of sodium carbonate into volume of sodium carbonate, that is equal to numerical coefficient in the balance equation. This is 2 by 1. Now M of HCl is not known, just take it as M. Volume of HCl, that is 24.89. Next is that M of sodium carbonate 1 by 20 as we have prepared. M by 20 we have prepared, we have just taken 1 by 20, and volume sodium carbonate, that is 25. This is equal to 2 by 1. From here M of HCl, this is equal to 2 into 25 divided by 20 into 24.89, which will be equal to 0.1 molar. Strength in gram per liter, that is equal to molarity into molar mass. Molar mass of HCl, not of sodium carbonate, that is 0.1 into 36.5, that is equal to 3.65 gram per liter. So this is the calculation part. Calculation, that is M of HCl by T of HCl, M of sodium carbonate, T of sodium carbonate, that is numerical coefficient of that particular constituent in the balanced equation. For HCl it is 2, for sodium carbonate it is 1, because 1 mole of sodium carbonate consuming 2 mole of HCl. Okay, next is that it is M of HCl is unknown, this is equal to 0.1 molar. Strength in gram per liter, that is molarity into molar mass of HCl, that is 0.1 into 36.5, that is equal to 3.65 gram per liter. So this is about the calculation, and after that we have to write the conclusion or result, then precaution. So again overall the points to be discussed: first aim, then theory, after that the materials required, then the procedure in brief, after that observation, calculation, result, and then are the precaution. Okay, you can choose any website, but be sure that these points are mentioned there. And I am telling repeatedly that don't take the data from there. You can just take the theory part, okay, but not that data, because the data will be different, because they may have prepared different strength of solution, different reading will be there, that will be different, only the theory part. Okay, now you can prepare, you can write. I am telling about that part that Anindo is inquiring, that preparation of standard solution of sodium carbonate. Okay, now at the first experiment I gave to you, that is prepare a standard solution of oxalic acid. Okay, now if you can write that another one experiment, it will be that number 3, that prepare a 250 ml M by 20 sodium carbonate solution as a practical. Okay, you can take it as a practical, that prepare 250 ml M by 20 sodium carbonate. Okay, just like the previous, you will write that you have written for the oxalic acid. The data part I shown you in the calculation. Data part I shown you in the calculation, that is 1.35 gram as it is calculated, you will take it. The observation part, as you have written on the first experiment, that initial weight, final weight, and the difference will be 1.325 gram. So in that way you will do it. Okay.